Hello everybody, welcome back to Kosmos. A quick video in response to some things I've been watching lately, particularly on a channel by a chap called Greg, and his channel's called Halligan142, and also in response to what I've seen going on in Germany with a chap called Stefan. So you must excuse me, I've got a bit of a cold again. So what got me thinking while watching Greg's video, or Halligan, is where he said that he was kind of decrying the dearth of projects around and project plans. And I'd like to introduce what I have found to be the fount of all project ideas, really, for little workshop tooling and equipment. And it is these two books written by a chap called George Thomas. So George Thomas is no longer with us, I'm afraid. A lovely old chap based in England and a prolific writer in Model Engineer magazine. And there we have a photo of him standing at his lathe, I think at one of the Model Engineer exhibitions, which I held annually in London and, other times annually elsewhere around the United Kingdom. You can see him at a Myford 7 Series lathe there. I think it's a Super 7 because it says Super 7 gearbox with a cigarette in hand. And really the degree of kind of easygoing scholarship that's gone into these two books, and he's got a third book as well, which is really a different version of this one. You see, this is the revised edition by a chap called William Bennett, and so there was the first edition, of course. I think this was published as a book in about the late 1990s, but in fact much of this material had been previously published in serialized form in Model Engineer magazine. And so I'll return to these books in just a moment, and there's another book I'd like to tell you about. If you can lay your hands on it, it would be a wonderful source of information. But one of the subjects of this book is a tool called the versatile dividing head. So again, there's been some discussion on other YouTube channels, particularly Mr. Pete, Lyle Peterson, who's given us a very comprehensive look at methods of dividing in the workshop, although he hasn't covered all of the methods, of course, and I hope I may be able to show you some methods that were not shown there, particularly as applying to cutting clock and watch gears, where a slightly different setup is sometimes used, or quite often in fact, where the headstock of the lathe is used as the spindle of a much larger dividing arrangement. But in the meantime, I'd like to show you the George Thomas versatile dividing head. Now, you'll have to hound Stefan because he's got a couple of videos just showing almost tantalizingly a little bit of machining he's done on his shaping machine and on his CNC little mill, where he'd been machining the body of this little dividing head, which is supplied as a casting, where you can buy the casting here in England, and they'll send the castings all over the world. So he's procured the castings and he was making this dividing head, and when we spoke he said he'd finished that but never really took much footage, and maybe he'd get around to describing about it, and I hope he does, because I'm quite ashamed to say that I've not made this. I bought it quite some time ago, maybe 3 or 4 years ago, and I've never actually had the opportunity to use it because I do mostly a different type of dividing, as I described earlier. This sort of thing isn't as useful for clock and watch wheels as it is for other types of engineering and tool making, but it is an absolutely wonderful versatile system. It comes in 2 pieces, and you can make each of them on their own. Well, really, this is the base unit. You can make that on its own, and it stands on its own as a dividing system, just as you see it there, or you can add modules. So this other segment is in fact two parts in one. So then there's that's the simple dividing arrangement, or direct indexing, which you've seen about, where you have a plunger that goes into a hole and then you just, index it round, and that depends on the number of holes you have there. And of course you could have a dividing plate with more rows of holes, giving you more options. The next step along is compound dividing, where you have a plate with holes connected to a worm, which then takes into this worm wheel here, and so you get far more options when it comes to the numbers of divisions you can create. And at first sight, that's not very different to, commercially available dividing heads. And so that's a little Jones and Shipman dividing head that I have for my mill. And in fact, I bought this after I bought the George Thomas one. So in fact, I should have made the point that the George Thomas one there in my possession would have been made by somebody like a hobbyist. It's not available complete commercially, to my knowledge anyway. It's a kind of project. So just swinging back now to the commercially available dividing head. So this is more of the kind we would have seen on Mr. Pete's channel, where you have a worm and wheel, and by turning the little crank we can index the chuck, or the forward end of the thing round as far as we want, given the constraints of the numbers of holes in the plates multiplied by the numbers of teeth in the worm wheel. So usually 60 to 1 ratio or 40 to 1 ratio I'm met with. Now, I can't remember offhand what my Jones and Shipman is. Actually, I do have it. But in any event, that is a classic kind that you'll see. So the question is, why not just buy one of these, which does direct indexing with a plunger, as you can see there, or compound indexing, compound dividing? Why go to all the trouble of making that? Well, I would say, first of all, is the great satisfaction in producing the thing yourself. Secondly, this has a little magical secret that I haven't described yet, which makes it infinitely more useful, literally, than the other type of dividing system. And I'll show you that presently. But before I go on, I'd just like to say that there is some very light surface rust in places on these tools, and some of it is rust. So for example, what you see on the edge of that plate is in fact rust, but some of this is dried on oil, and I've already started to do a bit of cleaning there with some nitromorse, which is paint stripper, which does very well at cleaning away solidified natural oils like animal and vegetable oils. But I think that this would have been machine oil, and so, petroleum based stuff. And so it's not as bad as it looks, this browniness. But whoever made this was an absolute master of his craft, a fantastic fitter and turner. Simply because everything is made to an exceptionally beautiful standard. I mean, just take, for example, even the simple fixings and fastenings. So that is a homemade nut, okay, and it's just sharp and crisp and really beautiful. The little bolts that hold the work together once it's assembled, now that's part of the designer's arrangement. There's got a little pin so that you don't need two spanners. You just pop it into the hole and that pin goes into a corresponding hole, so that all you're left with is a single requirement for one spanner on one side of the job. Oh yes, and I wanted to say for example, these screw threads. They're all single point cut on the lathe and presumably finished with a die, just to shape the crests, a beautiful, slightly rounded shape. So it's been made to an exceptional standard, and my hat goes off to whoever built this particular example. It is magnificent, and I think I paid at the time, as I say, about 3 or 4 years ago, about £400 for this, which I think is phenomenal value for money, because it would have taken somebody months to build this, really. I was looking at this part the other day, just this little plunger, which, okay, now it's, you know, it's got a little bayonet, and it's composed of 1, 2, 3, 4, 5, of 5 small pieces, 3 big pieces, or 5 pieces, 3 of which are big components. And I can take it to pieces in a few minutes and show you, but it's, you know, it's there's a lot of machining, lots and lots of different types of operation. There's knurling, that brass nut he's made there, little acorn nut. So the reason why you might want to make this, even if one could get something similar, not exactly the same, the satisfaction of learning how to do all the machining operations. Secondly, I would say that in addition to the fantastic educational resource that we have in the YouTube community, books like these, which many now do not know about simply because of YouTube, you know, if you just spend all your time on YouTube, which, you know, I do, you may never get the opportunity to read the delightful way that all of these operations are described. It's not just, you know, mount in chuck, take a you know 3/8 of an inch cut, you know, in so many steps. It's narrative. He's, you know, telling a story. You know, one of my Lancashire friends. You know, it's all done by chaps up in the north of England, where they're, you know, good salt of the earth folk. And really, these books are a pleasure to read. So there's that as well. You know, you're learning the side of one of the great masters when building something under his instruction. And finally, you'll get to have a tool that is like no other. And so the way this is different is this particular little piece here, which you wouldn't have seen on any of the other tools shown so far. This is the 3rd assembly, which again, the whole job can be created without this, but this is the little magical component. Oh, actually, am I doing the wrong thing? Take it off. Oh no, that's fine. Actually, no, I don't really want to take that out because it's been sitting for a while and it might be a bit gummed up. Anyway, this piece here, this block with that worm, and again there's one of those plugged bolts, and the micrometer drum, they are all a different assembly. So you could build that, then you could build the main compound indexing unit, which is fairly classic in its format. But the difference is that you've got this worm here. Now it's not a real worm. Oh no, sorry, it's not a real worm wheel, because a real, in inverted commas, worm wheel has teeth that look like that. So they cut with a circular cutter that's a representation of the worm that engages with it. So if that had teeth, that is the shape it would make on the edge of a metal disc. And in fact, that's slightly hollowed in the center. If you look along the core of that, sorry, just tilted it. If you look along the core, you see there's a little hollow just there. No, that's in the way, so you can't really see the contrast. Which is a little bit of relief for the belly of the worm wheel. So, by comparison, that is not a proper worm wheel. That is simply a spur gear, as is this. It's a slightly unusual spur gear in that the teeth are tilted at an angle, and that angle is the helix angle of the worm itself. So if you were to measure the angle that those teeth are tilted with respect to you know, the square plane, that would be the equal angle with with these teeth. So it's because it doesn't have to actually drive anything under load particularly, that's fine. You don't need the other type of worm wheel. And in any event, if you buy the castings and the kit of raw materials, they will supply these worms and worm wheels already made, and you have to bore them out and put these holes in them and so forth. But you don't have to make those. You could if you wanted to. But in any event, the idea behind this, and what it is called, is the micro attachment. So you've got a little micrometer drum. You see the index line or the fiducial line there. And this is divided into 60 parts. 40, 30, 20, 10, 0. Oh no, sorry, it's 100 parts. Yeah, it's 100 parts on the micrometer drum, and that is divided into 100 teeth. So you've got 1/10 of a degree resolution in one movement of this micrometer drum. So what that offers you, and let's just assemble the tool. So the tool as it stands here now is set up for direct indexing, where we have a plunger and holes with the most fundamental. If you want to make squares or six-sided objects or whatever, that's that easy, so simple, that's all you need. So the first thing to do is just to, well actually we need an Allen key, just to release this banjo. So, oh, they're connected. So release that and lock it, because you can park it out of the way, and then the whole banjo can move, and you'll see why in a moment. So then we undo the nut, push the little bolt out, keep the washer, get rid of that for the moment. There I will just show you the little captive bolt. So look how beautifully the maker has rounded both ends of that little pin, peg or pin. Look at that. The proportions, are they not just perfect? Right. So we remove that and replace it with similar setup on the compound part of the head. So we'll shove that through there. So the reason I had to move this banjo out of the way was because otherwise that will impinge. And also, when you're doing direct indexing, you might want the plunger somewhere else, for, you know, whatever you're doing on the milling machine or whatever, you might want the plunger here, or you might need it further around somewhere else. So that gives you some versatility there. We'll just leave it loose for the moment. And then, so this is the main worm to engage with this down below. No, I've got it upside down. So I'll just let it rest there for a moment. And I'll just snug that down. And so there's some lateral movement of the banjo, and so one would want it fairly well in the middle, but it doesn't have to be exact, because, well actually I think this entire spindle, no it's not, yeah, so just lock the banjo so that we have something solid to work against, and the whole thing does become a little bit off balance from this point forward. So I'll just steady it with my left hand. Right, and you can have it with really zero backlash, without, you know, mashing the gears into each other. But again, because there's no force being transmitted through this, merely a turning moment. So if this thing were designed to be running all the time, then you'd be very careful to allow some free play there for debris and things to get out, and, you know, lubrication. But that's not necessary when you're only, you know, turning it fractions of a degree at a time without any force being applied to it during the turning. And the whole tipping situation, of course, is ameliorated by the fact that this would be bolted down onto a machine. So the spacing between these holes, in this particular case, is designed to fit into the Myford boring table slots, which are, I can't remember what the pitch between them is, but they're the Myford standard, and those are Myford standard little T-nuts. So just putting it back on its foot, we can just give that a little hug with the old shifting spanner. Okay. Now, in this mode, you can operate the dividing head as normal. You know, take it through as many revolutions as you need for whatever ratio you want. And you can see as I turn that turns, which in turn turns the spindle. A word about the spindle later. And then these arms, you know, just to help you count or remember. So, you know, take a cut, and depending on what you're doing, you could do subtractive or additive positioning of these arms. And so you could do, say, so if you're doing subtractive position, you move it backwards while turning that forwards, say 1 and that many. And of course, please don't chastise me about backlash, it's just, you know, rough and ready. And if you're doing additive, then you go around to the next one every time. But that's all in the sort of theory of dividing. However, what this allows you to do, in as few words as possible, is to do prime numbers, or as close to prime numbers as anyone would care to get. So, with the dividing head, or any dividing system like this, you can calculate if the number you are trying to divide to is capable of being reached if its prime factors are available to you either in the worm or in the number of holes that are available to you in your plate. So if, for example, this, which has 60 teeth, so we've got 2, 3, 5, yeah, well, off camera I'll probably get that answer more easily, but I think 2, 3 and 5 are the only prime numbers, or the lowest prime numbers available to you if you're trying to get 60 holes, say. What if you're trying to get it, sorry, I've lost my train of thought. Basically, any number of holes you're trying to reach in your dividing job must be offered, that number of holes must be able to be reached by all the primes in this and all the primes in the whole circle that you have at your disposal. So we have many whole circles at our disposal, but you know, there might be 10 and 20. So there's some duplication and therefore some loss of possibility in that arrangement. And that's why the choices of holes are very carefully decided by the designers of these things, so as to give you the most prime factors. However, prime numbers themselves do not have prime factors other than number 1 and themselves. And of course there is a strong argument that number 1 is not a prime number. Let's not go into that for just a moment, for the present. But in any event, the implication of that is you cannot reach any prime number without having that number already pre-prepared in one of these holes, in one of these hole circles. So if you wanted to cut 127 teeth in a gear, and that's fairly common. For example, when you're doing metric to imperial translation gearing, if you want to convert metric to imperial, you need a 127 tooth. That's the easiest way to do it. But 127 is a prime number, so you can't multiply any two numbers to get 127. So the only way you do it with the dividing head is to have 127 teeth circle. Maybe you do, but maybe you don't. What this does is allows you to arrive at prime numbers by a little bit of mathematical chicanery. Because it doesn't give you a real prime number, but it gives you to within 1,000th of a degree of your target. And really, if your job requires you to get into 1,000th of a degree precision, or better than that, well then, you know, you'd be using other methods. And the other thing about that is that whatever that error represents, you know, smaller than 1,000th of a degree, is going to be divided equally all the way around the circle. It's not all going to be bunched on the last tooth. And so the way it works is very simple and very clever. You calculate the angular movement required and convert that into numbers of rotation. So say you need, you know, actually, there's an example in the book that says 76.18 degrees, I think he said. And he said, well, say you could get to 76 degrees by moving, and that's, you know, another simple arithmetical check, by moving your plunger, say, 38 holes from, you know, from one position to the next. So, you know, say that's where you are. Say for argument's sake that were, you know, the 38 hole span that you required. Well, let's call it like, really, I'm over egging it. Let's do it for real. Well, there is a 38 hole circle. So actually the example given by George Thomas in his book is interesting because the little tool is used to generate its own plates. And these plates, three are shown in the, you know, in the designs, but, you know, the description exists of how to make more. So that's got 78, 66, 50, etc. That's got 60 holes, I think. That's the first one you make. And this one, okay, so there's 31. So just there you see 31 holes. So somebody's used the dividing plate to make a prime number of holes. Now, there are geometrical methods whereby you can arrive at an equal number of divisions using dividers, for example, or, you know, there are other ways. But the way to do it is to work out in degrees the space between one hole and the next. Now, don't forget, I shouldn't deceive you, or the job would be mounted on a chuck here, and this would be on the lathe table, and you'd have the drill coming in, drilling the hole in a fixed position, and then you would advance this whole thing round, and then drill another hole, advance it round, and drill another hole. So in this part of the job, the space between one hole and the next, for the sake of argument, for a prime number, you would convert to an angular difference. So you work it out that maybe that is, you know, 3.78 or 3.73 degrees, which I think is probably a prime number. In any event, you then get it down to the nearest hole angle, work out how far that means you have to move this, which is back to where we were before. I need to set this distance here, that's why this is jamming slightly, because this distance isn't quite comfortable. I don't like shifting spanners, but I also don't like rooting around my toolbox for 20 minutes to find the right wrench. Okay, so I'll just snug that down by hand. Yeah, okay. Okay. Right. So we move the plunger to the right position, and then whatever the remainder were in degree, in hundredths of a degree, so you round it up to the nearest hundredth, you turn this forward or back, because you might want to do it subtractive, because you might have, you know, 3.998 degrees or something, or 3.98 degrees, which means you just move that back by 2/10 or 2/100. Or you might have, you know, 3.46 degrees, in which case you might want to move this forward by 54 to get to the next whole number. And what this does is, as you see, it's moving the entire arrangement. So the dividing plate's moving in increments, really, or in quanta of 1/100th of a degree. Well, that's where, in theory, that's where you're meant to stop each time, is on one division. So, and the plunger, and therefore the spindle is moving as well, which means that that worm is moving very, very slowly, which means that this is moving very, very slowly. So you are able then to settle on, because that's got 60 teeth, that's got 100 divisions, and that's got 100 divisions. So that's 100 division, and that's 600. And we're working with degrees, so you're down to 1,000th of a degree. And so that's why the versatile dividing head is by far and away the most versatile dividing arrangement that you could possibly have in a mechanical system. Of course, these days we do get electronic systems, and I do have one of those, which I can show you in a separate video. As a project, what a wonderful project. You use the tool to build itself, because to begin with you have no dividing plates. In fact, you don't even have one with 60 holes. You have a blank plate. So, you know, how do you make 60 holes when you don't have any holes to begin with? Well, George Thomas will tell you. So I would thoroughly recommend, even if you don't make that tool, and I haven't, and as I said, I'm a bit ashamed that I never got around to making it, but when I saw one for sale I just bought it, because actually I quite enjoy my clock and watch making. So but I do love tool making as well, but I realized that the much time I spent tool making wasn't spent clock making, and so I've had to take a view on that. So workshop techniques, and its accompanying volume, the Model Engineer's Workshop Manual. So I'll just very briefly go through a few features of these two books that you might find entertaining. So I've shown you the picture of George Thomas. This you're going to love. Well, actually you will in a second, I'm getting to that. I'll get back to that, because this is another tool, very useful tool that's described here as a project. This is a bit you're going to love. Photos of the old boy's workshop. So a tiny space, so that's not all of it obviously, he has a milling machine there and some other stuff. You can see absolutely filled to the gunnels. Every square inch is covered with something, but he's got some sort of 1970s radio there, or maybe that looks like an 80s radio receiver. He's got his universal pillar tool, which is another tool described in the books. What appear to be chemicals or paints or something. Lots of jars there. Probably screws and nuts and bolts. Don't forget, the purpose of all of this was to make model engines, and so all the tools were there to make the model engines. And so a lot of the stuff would have been for model engine building. And then over on the left he's got a horological lathe, which is my favorite thing in the world. So that's, it looks like an 8mm lathe, lots of beautiful collets, an overhead drive. He's got attached to it a kind of lapping arrangement that floats, called a wig-wag, and it kind of pivots that way very lightly, and he's got a lap. So you see the circular lap just there, so that will spin around its own axis along there, but also wig-wag slightly to and fro, and if you say had a screw head held in the chuck, and these two were rotating at the same time in opposite directions, while the lap was passing to and fro across it, you get a beautiful dead flat surface with black polish or very deep flat optical polish. And so that's his horological machine, but not used for horological work, but just for advanced model and tool making. And so, well, there's a photo of some of the setups that he illustrates that you can use a dividing head in. So you can even mount the dividing head on the vertical slide of a Myford lathe. There it is doing something else on a vertical slide. Because of that moving banjo I told you about, you can put the dividing objects like the index plunger or the compound arrangement in any orientation kind of thing. And he also describes how you can make this on a smaller lathe than a Myford or a bigger lathe, or how you can do dividing on bigger lathes. And throughout it is riddled with little anecdotes and sort of friendly behind the scenes look. I've landed here on a page of one of the other subjects of this book, which is the universal pillar tool, which is a sensitive drill with a large table. It has a tapping arm whereby you can do hand tapping, so you've got a perfectly vertical alignment of your taps so that they don't get broken off if you're doing very, very small holes. It can also be used on the lathe, so it's got a foot there where that can be mounted on the lathe and you can do kind of radial work on the lathe. And then further back he describes how you can use it for clock bushing, turn it into a bushing tool. There we are. So there's a clock plate, and what you've got is a kind of stake and punch arrangement, but interchangeable cutters and reamers and punchers and riveting tools, which would be used by clockmakers for repairing worn holes in clock plates. And so you've got little finger clamps there that will clamp the work down, and so the work won't move while all the bushing operations are carried out on it. So that's described. And one other thing that reminded me to check is the staking tool. So again, that's a kind of semi-horological, well, it has its origins in horological work, but you know, others have found it useful. So where you've got the facility to perfectly keep upright a punch and the supporting stake below it with a variety of holes that can be brought into play. And I love this. You see how the holes are all apparently equal spaced around that circle. Well, of course they don't have equal spaces between them, but optically they appear to have the same sort of balance. And they are imperial holes, and it gives a table which takes some working out. The size of the hole and the angle in degrees that you'd have to twist the thing around by before drilling each next hole. And of course, it's been produced using his universal pillar tool. Using his versatile dividing head. The book I don't think is very commonly available, but I think you can find it on Amazon and AB Books or Abe Books. But certainly you can buy this book from Hemingway Kits, who also sell the castings. The casting set for the whole dividing head I think is £145-ish. But you can buy just the castings and the necessary crucial bits like the worms and castings without all the bar stock. So you say if you lived overseas and you didn't want people to be sending you, you know, bits of iron really that you had lying around your own workshop, just to send the important stuff, you know, they'll do that as well. A very, very accommodating company, Hemingway Kits. I'm not associated with this author or Hemingway Kits, by the way, just in case you get to wondering. This is the other book, and this is chock-a-block full of projects you can make. So a scribing block and ruler holder or rule holder, different types of parting off. how to make beautifully proportioned ball handles, a retracting tool holder, and it goes on to describe a retracting top slide, so a bit like a hard-hinge lathe, a retracting top slide for screw cutting. So with a flick of a lever, little tiny lever, the whole top slide pulls back by a certain amount. So when you reach the end of a cut, you just flick the screw cutting cutter out of engagement, drive the carriage back, flick it back in, take your next cut. And I put some bookmarks in. Oh yes, so this is something I'm definitely going to make. It's a boring bar, but it's a boring bar with a difference. Because you know when you see boring being done with a boring bar, between the centers boring bar, I should say, not one of those kind of boring bars, the kind of boring bar that's driven from a chuck and held at the tailstocks for boring, well, this sort of thing. When this was made, a common way of making this would be to bolt that onto the lathe cross slide and put a boring bar straight through there and bore it, you know, with a carriage driving the work past a cutter mounted between centers. But that kind of cutter invariably is very difficult to set because it involves, you know, unscrewing a set screw and then tapping it lightly and miking it. Well, George Thomas, of course, in his usual scholarly sort of way, set about improving that. So what he's got is a cross screw there with a taper, which impinges on a locking rod that presses against the cutter. So when you want to change the cutter setting, so in other words, push the cutter out further, you don't need to get anywhere near it. You just undo that screw, slack that screw off slightly, and you notice it doesn't put any force along the direction of the cutter. It pushes it sideways, so it's not going to tend to move the position of the cutter just as you're fastening it, right? And then, and what it's got as an adjusting screw for the cutting bit is a 40 thread per inch or 40 TPI thread, and this is at 40 degrees or 45 degrees. I think it's 40. Yeah, so that's out at 45 degrees. And he's worked out that one turn of the, one full turn of the screw gives an 18 thou advance of the cutter. So it's very easy then to sort of turn the screw roughly, you know, halfway or roughly a quarter of the way and get really fine incremental advance of the cutter without even trying. And the reason he's put it at an angle is very clever, because it means you can put a mic across there. So the mic bears across solid metal, whereas normally these are plunged straight across the boring bar. It means you can never get a micrometer. Where you want to put a micrometer, you've got a little hole. So it's always a massive pain to mic across that distance, but not so when the cutter's at an angle. So you just put a mic across that distance there, and you've got solid bar, and you can measure the exact diameter of your next cut. So that's one thing I'm going to make. You can see there is reaming the hole for the quarter-inch round cutter. And so what else have I got? Oh yeah, I love this. He's gone into the, you know, why he thinks that certain ball handle sizes and shapes just work and others don't. And he's also asked the question, well, why are ball handles the way they are? Why do we not have the small end going into the work with a big end on the kind of flying end of the ball handle? And you know, a couple of paragraphs as to why, you know, he's worked it out. And I shan't bore you with reading it, or I should say I'll tantalize you by not reading his reasons. And they're pretty good reasons. I'll leave you to discover that for yourself. Oh, here's a nice piece about square knurling. So, how to make beautiful square knurls, look at that. And not necessarily about square knurls, but he's said here, where was it? Oh yes. So it says, while I was taking some of the photographs for this chapter, I was impressed, and by no means for the first time, with the excellent appearance of some of the knurled parts of my Zeiss Contour-X camera, I decided there and then to try something of the kind myself. The results can be seen in the photo 103, and most people who have seen the actual samples have agreed that they look very elegant. Now, ironically, photo 103 is an awful photo, and bear in mind this black and white reduced size pictures don't reveal much, but I believe that the photo 103 is more or less, that is the same object as seen here, and you can see that is reproduced his Zeiss camera Knurling on his micrometer, on his cross-slide micrometer. No, in fact is it a cross-slide micrometer? Yes, it is. So little snippets like that, just to cheer up your day. Oh, that's a very interesting thing about how to make very good locking arrangements for your micrometers, rather than just having a grub screw that, you know, clamps straight down. He loves his levers and wedges. Oh yes, there was something amusing here as well. He describes how before he had a little rotary table, he would be rounding the ends of some steam engine parts, and using the component itself as a lever, rotating the end against an end mill held in the chuck of the milling machine. The difficulties and dangers of this method are that one can easily take the cut too far and pass the scribed line, blah 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 blah. There is also the wear and tear on the operator due to near heart attacks. So you know, he's not above a little bit of risk taking and admitting it in print. And all in all, an absolutely thoroughly engaging book, chock-a-block full of projects. In fact, a lot of the things you now see for sale as Myford type accessories are in fact George Thomas's ideas, first elucidated in the pages of Model Engineer, later in this book, and later produced commercially. So for example, that is a four-way tool post, the so-called Gibraltar tool post. There is also the rear parting off system. So wherever you see rear parting off, well, you saw it here first, because he's been promulgating that since the 1940s. Well, of course, you know, others may have done it independently, but certainly George Thomas has been on about rear parting off tools for a very long time. And he's also gone into the reasons why, on a small lathe, rear parting presents often fewer problems than normal parting. So thoroughly to be recommended. The last book I would say, I think this guy's Canadian, Guy Letard, and I believe Guy Letard is still a kind of going concern, hopefully he is. And he published these books called The Machinist's Bedside Reader, The Machinist's Second Bedside Reader, The Machinist's Third Bedside Reader. And he goes into great detail about many things, and his kind of take on things back in the 1980s, I suppose, and 1990s when these books were published, was he had his guys, as he refers to them in the books, that would use him as a kind of hub or server of information. You know, that's before the internet, and they would write to him and say, hey, I read your book, and you know, you mentioned something about parting off. Well, this is the way we used to do it, and then he'd include it in the book in the writer's own words, and say, you know, well, this guy wrote to me, a really friendly, really kind of another kind of real salt of the earth character. I happen to have just opened coincidentally to this page, How to Give Your Keyless Chucks a Deluxe Overall. Now, Tom Lipton's just described on video how to do this, but of course there's nothing new under the sun, and Guy Letard, oh yes, in Vancouver, had written how to do that probably in 1993. Look at the colour file there. Copyright Guy Letard 1993, this edition from 2007. So this information's been around there all that time, but you know, it is kind of trapped between pages and pages like this. So you know, it's quite engaging watching somebody do it on screen. But what I love about it is he always gives credit to where the information came from. So look what he says there. Look at what he says. He says, keyless Albrecht chucks are another matter. So he started off by saying disassembly of key chucks. Keyless Albrecht chucks are another matter. They come apart quite easily if you know the trick of it, but if you don't, you could spend all day diddling around with one and still be no further ahead. And I don't even get me to try and emulate a Canadian accent. When I was looking into this, I ended up talking to Ed Schmidt at Albrecht Inc. In Happoge, New York. Oh, sorry. I should have carried on reading. That's pronounced Hoppoge or Harpog, by the way, maybe. Horpog, New York. And he told me a few things. So, you know, he cited the source of the information. He's given, you know, very clear instructions like, that's that. Jaw guide, make no mistake. And he's got, you know, the extra goodies, and there's somewhere here the deluxe part of the job that they don't tell you about. So, yeah, if you want to, when the revolution comes and there's no more YouTube and no more internet, let's hope you've got a copy of the Machinist's third bedside reader. How to make, oh, he's big into his gunsmithing. So the English seem to be very big into model engineering, whereas Americans and Canadians are into guns. And so a lot of his information in his books is about how to chamber Reamer chambers, you know, the trigger arrangement for a Mauser, lots of gunsmithing tips, which has a great overlap, say, into general metalworking, clockmaking. What's that? I think that's his high pressure hose, a sandblast gun machine from a block of steel. He does have a high pressure hose pipe tip. How to sharpen your reamers. There's a whole thing on how to sharpen reamers. These books are very difficult to get hold of anyway for me here in England. They were very expensive, and I think I bought them from an English book dealer. But, you know, really, considering what they are, they were outrageously expensive. I bought them about 7 or 8 years ago. I've got the whole set, including the final one called Hey Tim. It's all these names. And a lot of the stuff is written in kind of narrative form, like, in my opinion, quite sort of twee fiction, but, you know, where it teaches you how to do something in the storybook, like young man hangs around with old mentor, learns how to do case hardening, that kind of thing. But really, Greg and others, if you're looking for projects, you will find more than a lifetime supply in those 3 books alone. And now for something I was probably put in a separate video, something quite exciting for me anyway. Exactly what it was, and I saw it on the doormat. Postman had dropped it through the letterbox. So this has arrived from America, and this might give you a clue. Well, it's not a clue, it's in so many words. The Support Ox Tool Co t-shirt. And there should be 2. And I didn't know if I should go for a large or an XL. So I've gone for the XL just in case. The shipping was as expensive as the t-shirts were. Yeah, that does look rather big even for me. So I've not yet ventured to the front of the camera, although I think if you watch some of my very earlier videos, the very long and boring ones, well, I think this one's quite long. If you watch some of the ones about, making a microscope, which I haven't finished yet, you might see parts of me. But yeah, so I got a couple of these American Apparel Ox Tools t-shirt in the Ox Tools appeal. So why is the colour gone all, oh yes, I'll just readjust the exposure. And no, I'm not going to get in front of the camera. I don't think you're ready to, I don't think the internet's ready for the horror that is me. But I can assure you that as of this very moment, oh yeah, Yeah, that's quite a good fit actually. Great. Tom, that's a great t-shirt. I'm really looking forward to wearing that. Super. Yeah, and I think that if you hurry, you can probably get the next round. So I think whenever you go to this I think it's Teespring, when they reach the threshold for minimum order kind of thing, they'll make another whole batch. This was from the first batch. Pretty stoked that they've arrived, and yeah, that's it. So a suitable end to quite a long and wordy video. Not much going on, but yeah, I hope somebody will get benefit by reading these books, building the projects involving them. In fact, I built quite a few of the projects, and I'll at another time show you some of the things I've made. I have referred to them in conversation in some of my other videos, some of the projects out of this book, which have been re-envisioned by Hemingway Kits. So Hemingway Kits are the official successors to the people who made and supplied the castings for all of these projects, and you can still buy them, and they're beautifully done castings, and the drawings are exceptional. Although I think for these two projects you need to buy this book, because all the notes, it's incredibly comprehensive. It's not just a case of, make these parts exactly like this and then put them together and the thing will work. Yeah, but it's the progression, it's the learning how to do things, it's a building on what you did in the previous chapter. And believe me, you will spend hours and hours just reading and being absorbed, and in your mind you're making the thing even though you haven't made it, which I suppose is why I ended up buying one. But these cannot do without books, and I think I'm going to spend many a happy hour making some more of these projects, particularly that boring bar, while wearing my Ox Tools new t-shirts. So thanks very much for watching, and see you next time.